Hi everyone, welcome to Microbiology and Parasitology Laboratory. This is exercise 12 and it's all about the acid-fast stain. In this exercise, you should be able to understand the steps or the procedures for acid-fast staining and be able to distinguish between acid-fast and non-acid-fast organisms. So here is a picture illustrating the difference between the cell walls of gram-negative, gram-positive, and mycobacteria. As you can see, the cell wall of mycobacteria, or example Mycobacterium tuberculosis, which is the causative agent of TB, consists of high lipid content, or mycolic acid layer. It is hydrophobic and impermeable to gram-stain reagents. It requires heat and or phenolic compound to enhance absorption of the primary dye, which is carbonyl fusion, and to penetrate the cell wall. Decolorization is done with 3% acid alcohol, followed by methylene blue or malachite green as counter stain to stain the background. There are two kinds of acid-fast staining methods, the hot and cold method. Ziehl-Neelsen technique, also known as the hot method, simply because heat is applied to melt the wax or mycolic acid layer and to facilitate absorption of carbonyl fusion with 3% phenolic compound into the bacterial cell. If the bacteria resist the decolorization by acid alcohol and retain the primary dye after counterstaining, they are called acid-fast bacilli. On the other hand, we have the Kinyoun staining procedure, wherein the application of heat is removed, but a higher concentration of 10% phenolic compound in the primary dye and longer staining time are required, hence known as the cold method. This method has higher sensitivity, specificity, and efficiency than the former. However, sputum smear microscopy is no longer the initial test used in the bacteriologic detection of TB because of its low sensitivity compared to TB culture and other molecular diagnostic tests. It requires at least 5,000 acid-fast bacilli per ml of sputum compared to at least 100 AFB for TB culture to yield a positive result. Diagnosis of patients with few TB bacilli in their lungs would usually be missed in sputum smear microscopy. In addition, bacteria like Nocardia, Legionella, and cysts of Cryptosporidium and Isospora can be stained by these methods as other acid-fast organisms. So for the procedure for Kinyoun staining method, of course, you need a smear. By the way, there is a recommended size for AFB smear, and that must be 3 centimeter in length and 2 centimeter in height. So 2 by 3 centimeters. So first, cover the smear with filter paper and then flood the filter paper with Kinyoun's carbonyl fusion. Then allow the smear to stain for 5 to 10 minutes at room temperature. So what is the purpose of filter paper? So this prevents the evaporation of our primary dye or primary stain, which is carbonyl fusion. Since Kinyoun staining method is a cold method, so the application of heat is omitted from this procedure. You just have to let your primary dye to stand there for 5 to 10 minutes. After that, wash off the stain with water, then tilt the slide to drain. Discard the filter paper in a designated container. So you wash your slide with running water and then decolorize with 3% acid alcohol for 1 minute. So in gram staining, we have 95% alcohol that serves as our decolorizer, while in AFB staining method, we have 3% acid alcohol for decolorization. Rinse well with water and then counter stain with methylene blue for 1 to 2 minutes. If methylene blue is not available, you may also use malachite green as a counter stain and let it stand for 1 to 2 minutes. After that, wash off the stain with water, then air dry. So after washing the stain with water, observe it, or after air drying, observe your slide under the microscope. So how do we read our slide? Place 1 drop of immersion oil on the stained smear, then examine the smears side to side under oil immersion field using an imaginary line at the center of the 2 by 3 centimeter smear as shown below. So this is where we read our slide at the center. Confirm the presence of acid-fast organisms as follows. Acid-fast bacilli appear as thread, single, thread-like, straight or curved, and may occur in clumps. Other cells appear blue if methylene blue is used, while green if the counter stain is malachite green. The same with the background. Blue for methylene blue and green for malachite green. This is an example of a stained smear. So here are your acid-fast bacilli. So there are lots of AFB in this picture. Then proceed to the reporting. Report the result based on the World Health Organization and IU-ATLD interpretation guide as shown below. So if there are no AFB, it is reported as negative, but if you are able to count 1 to 9 AFB in 100 visual fields, it means it is positive, scanty, and it is reported as plus n, where n is the exact number counted. Example, plus 9. 10 to 99 AFB in 100 visual fields is reported as 1 plus, while 1 to 10 AFB in at least 50 visual fields is 2 plus. But if there are more than 10 AFB in at least 20 visual fields, it is reported as 3 plus. So this is a 1 oil immersion field, and that is equivalent to 1 visual field. So if this is your smear, this portion here from side to side is equivalent to 300 visual fields. So you have to cover this whole portion here. And if there were no AFB seen from side to side, it is reported as negative. Now, if you were to divide it into 2 equal parts, that would be equal to 150 visual fields. So if there are 3 equal parts, or if you divide your smear into 3 equal parts, that would be 100 visual fields each. Example, you were able to count 1, 2, 3, 4, and 5 AFB up to this portion. So that is equal to 100 visual fields. So going back to our table, so it says here that if you were able to count 1 to 9, so we have 5 in 100 visual fields, it is reported as plus n, where n is the exact number. So how do we report our result? So that would be reported as plus 5. Now, I want you to try counting the acid-fast bacilli in this visual field. So I'll be giving you 30 seconds and try to count as many as you can. Timer starts now. You have 10 seconds remaining. Okay, so how many acid-fast bacilli were you able to count? Let us see. We have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So we have 16 acid-fast bacilli in this visual field. So let's try counting in another field. So again, you have 30 seconds to count. And timer starts now. Ten seconds remaining. Let's begin counting. We have 1, 2, 3, 4, 5, 6, 7, 8. So let's say we have 8 acid-fast bacilli in this visual field. So this is the second visual field, so we have to add the first one. So we have 16 plus 8, and that is equal to 24 acid-fast bacilli. So how do we report it? This is already reported as 3 plus because looking at the table, so if you counted more than 10 AFB, so we already have 26 AFB in 2 visual fields. So that is already reported as 3 plus. So that's how you do your acid-fast staining and the reporting of AFB. So I hope you learned something from this session. Thank you.